In the last section, we took a look at how we could find the probability of an event that was affected by the likelihood or the probability of other events that had happened in the past. So we had this idea that events were conditional or dependent on each other in some way, that something that happened before could affect something that happens next. Well, in this section, 3.4, we're going to take a look at when that sort of scenario does not occur. That is, when one thing happens, it does not affect the probability of another. So these sorts of events are what we would refer to as independent events. So here's kind of the idea. Events A and B will be called independent if, and only if, the statements that are listed here are true. Notice that this says the probability that B happens given A, so if A already happened, what are the chances of B? If that's identical to just asking the question, what are the chances that B happens, then these events are independent. You can think of a lot of examples like this, right? So you might ask something like, what's the probability that I get an A on my statistics exam, given that it's raining in California? Right? Like, those events don't seem to have any relationship to one another. It doesn't seem like rain happening in California has anything to do with your performance on the exam. You might as well have just asked the question, what are the chances I get an A on my stats exam? And so this should be able to work both ways. If I reverse the order, what are the chances that it rains in California, given that you got an A on your exam? You should just be able to narrow that down to, what are the chances that it rains in California? Okay? So independent events are events that do not affect the likelihood of the other event happening. And that's what I state down here. Events A and B are independent if the occurrence of the event A does not affect the probability of the event B, and vice versa. Events that are not independent are called dependent. That's what we saw in section 3.3. We had dependent events where A did affect B and B did affect A. However, notice that if these events are independent and this property here is true, this allows us to take our multiplication law from the last section and really simplify it down. You may recall that we had a multiplication law that said if I wanted the probability of A and B, I could calculate that as the probability of A times the probability of B given A. But if my events are independent, then ultimately I can just say, asking what's the probability of B given A should be the same as just asking what's the probability of B, right? Because A has no effect on B. And so in essence, I can upgrade my multiplication law when I have independent events. And it can say that when I have the probability of A and B, that's the same as saying probability of A times probability of B. Okay, now this can be a lot here at the start, so it's important to narrow down a couple things. First off, we know that this formula here in red worked when I had dependent events. However, if I end up with independent events, this formula can be updated to a simpler version. It's also going to be the case that I can kind of use this blue formula down here to confirm that events are independent if I'm not sure if they were independent from the beginning. And we'll see a little bit more about how to do that in the next video.